A very good morning to our lecturer, Mr. Muttada, and my fellow friends. I am Kovelanraj Rajan here with my teammates, and my matrix number is 10 DDT 21F11 and 11. Today, in this fresh morning, we are here to explain the case study of discrete maths. And my part is the introduction. So let us study it. The Kruskal's algorithm. The Kruskal's algorithm is a minimum spanning tree algorithm that takes a graph as input and finds the subset of the edges of the graph which form a tree that includes every vertex, as the minimum sum of weights among all the trees can be formed from the graph, and also the binary search tree. A binary search tree is node-based data structure in which each node has no more than two child nodes. Each child must either be a leaf node or the roof of another binary search tree. The left subtree contains only nodes with keys less than the parent node. The right subtree contains only nodes with keys greater than the parent node. Start with a tree containing just one vertex, namely the root. The first item in the list is assigned as the key of root. To add a new item, first compare it with the keys of vertices already in the tree and move the left if the item is less than the key of respective, or move to the right if the item is greater than the key of respective vertex. And the last part is a complete binary tree. A complete binary tree is a type of binary tree in which all the levels are completely filled, have two children, except the possibly the deepest level. The deepest level can have nodes that can have either one left child or can be completely full. A complete binary tree can be fully binary tree when the deepest levels are completely full. Thank you for your attention, and now Mr. Vinosan will take over.
Thank you, Kovelanraj, for your explanation. Okay. A very good morning to our lecturer, Mr. Mutara, and fellow friends. So, my name is Karthikesen, and my matrix number is 10DDT21F1114. For my part, so I'm going to talk about the environment of the selected area. Okay, this area is located in the city of Shalom. This is a very busy city and contains a lot of shop lots, restaurants, clinics, schools, and universities. Okay, these are the main objective of doing the case studies. Firstly, to obtain the basic knowledge of Kruskal's algorithm, binary search tree, complete binary tree, and their implements. Secondly, to understand the importance of graphs and trees in the context of the world of technology. Then, to develop skills to apply the knowledge of the graphs and trees in problem solving. Okay, for task 1, this is the question. As a manager in a telecommunication company, you need to plan how to lay cables of a cable internet network service between 10 places in an area. Laying cable is very expensive, so you need to keep the total length of cable as short as possible. Make sure all the locations are connected. They do not have to be connected directly, as the signals travel along the cables at the speed of light. What is the shortest length of cable required now? Okay, here I'm going to choose 10 locations: shop, lots, house, company, school near my neighborhood. So I'm going to get my map from Google Maps together with the distance between them. Okay, these are the map. So okay, we have choose and marked 10 locations. Then we have connected all of them by drawing lines to measure the distance between all of the 10 places. Okay, secondly, we use Kruskal's algorithm to find the shortest distance that connect all the 10 locations. Then we redraw the locations and the selected distance. So you can see here, we redraw it and we draw a line between all the 10 locations. So finally, we calculate the shortest length of cable required. The shortest length of cable required is 4,165.65 meters. These are the 10 places we listed located here. So that's all from me. So Next, my teammate Yogandas will present the next task. Thank you very much.
Thanks to Vinosan. A very good morning to our lecturer, Mr. Muttada, and also to my fellow friends. I'm Yogandas Aridas, and my metric number is 10DDT21F1112. So I'm gonna continue our presentation with binary search tree. For binary search tree, we start with containing just one vertex, namely the root. So in our binary tree, the root is Patin mania. Next, to add a new item, first we have to compare it with keys of vertices already in the tree and move to the left if the item is less than the key of the respective, or move to the right side if the item is greater than the key of the respective vertex. Now you can see in our binary tree, we compare the first letter place that we choose. So as you see, we located clinic azima on the left under the Patin mania because the first letter of the clinic azima is lesser than Patin mania. Next on SMK section 7 is 1 the right side under the Patin mania because the first letter of the SMK section 7 is greater than the first letter of the Patin mania. So at the first level, the Capsicum Steamboat will be on the left and the Mars International School on the right under the Clinic Azima. After that, at the second level, the Polvero Stick House on the left side and the University Selangor will be on the right side under the SMK Section 7. Finally, at the third level, for the Capsicum Steamboat on the left will be the Al Rasha and on the right side will be CRG Chicken Rice Guys. Then the last place, which is Restaurant Hakim, will be on the right side under the Paul Pero Stick House. So now I'm gonna answer the question, which is they ask about root. So the root in our binary tree is Patin Mania, and the leaf is CRG Chicken Rice Guys and also Restaurant Hakim. For internal note, we put Patin Mania, Clinic Azima, SMK7, Shalam, Capsicum Steamboat Section 7 and also Polpero Stick Out Section 7. For the height of the binary tree is 3 and the degree of the binary tree is 2. So that's all from me for today, and I'd like to invite my teammate Sugakesshaa to continue our presentation. Thank you.
Thank you to Yogandas. A very good morning to our lecturer, Mr. Murtada. I'm Sugakesshaa and my metric number is 10DDT21F1109, and I'm going to continue on the complete binary tree. First of all, we place the root, which is the Patin mania. As we all know, the complete binary tree, the nodes, the branches must be starting off the left. It must be as far as left as possible. So, and also it must be based on the order. It must follow the order of the places. So the second one is Clinic Azima, so it must come on the left. And the Capsicum Steamboat Section 7 is the third one, so it automatically goes to the left. It goes to the right. As the first level is finished, now we go to the second level. We need to place the Mars International School and Al Rausha under the Clinic Azima, which is the fourth and fifth in the order. And then we need to complete the second level, so we need to place SMK Section 7, Shalam, and the University Selangor under the Capsicum Steamboat Section 7. Now that the second level is completed, we go to the third level. The third level, we need to place CRG Chicken Rice Guys and Paul Pero Stick House Section 7 under the Mars International School. And then we place the Restaurant Hakim under the Al Rausha. Now that our complete binary tree is completed. Next is discussion. For task 1, first of all, we have chosen an area in the Google Maps application. Then we picked 10 places from the map. We then connected all 10 places we chose and measured and then marked the distance between each place. Finally, we used Kruskal's algorithm to find the shortest distance in the map for the cabling. For task 2, we created a binary search tree from the above list of location and answered all the questions. Then we did a complete binary tree from the above list of location. Next is conclusion. In conclusion, we have gained lots of knowledge of Kruskal's algorithm binary search tree, complete binary tree, and also how to implement them correctly. We hope that we understood the importance of the graphs and trees in the context of the world of technology. That's all from us. Thank you.